Welcome to Impact Phase. We'll be dealing with essay question 10 CII Waec 2023. So let's progress. I'll read for you. The question reads: a piece of coin falls accidentally into a tank containing two immiscible liquid A and B. As illustrated, calculate the displacement of the coin when viewed vertically from above. Refractive index of A equal to 1.3 and refractive index of B equal to 1.4. Okay, we are asked to calculate the displacement. The idea is that when an object is inside a liquid, if you view the object, it will appear as if the object is nearer to the surface than it is. So possibly the eye sees the image of the object, not the actual object, because the object is very closest to the bottom, but you may interpret it to be that the object is nearer while you are seeing the image of the object. So let's progress. So the distance between this apparent depth and the real depth is what we refer to as what? The displacement. Distance between the apparent depth as it appears and where it is actually is what we call what? The displacement. So but we have two immiscible liquid. So we are going to calculate the apparent depth for B and we'll calculate the apparent depth for what? For A. By the time we subtract the total apparent depth from the real depth, we'll be able to get our displacement. So let's start working. So from here, we are going to have N for B will be equal to the real depth of B. We'll call it D, real depth of B over the apparent depth of B. Let's call it 1. So now, what are we going to have? We're going to have 1.4 equal to real depth of B is actually 8 over what? Good. So by the time we cross multiply, we're having D1 equal to what? D1 times 1.4 equal to 8. So our D1 should be equal to 8 divided by 1.4. What do you have? So let me use my calculator, please. So I'm going to have 8 divided by 1.4, and then I'll have 5.7. I'm having 5.7 cm. Okay, so let's progress. So let's calculate the apparent depth for A. The apparent depth for A, real depth for A over what? Apparent depth for what? For A. If we do that, what do we have? We're going to have 1.3, which is the refractive index of this. Now the apparent depth will be what? Will be 40. Is already given. Sorry, the real depth I mean to say. This is the real depth. 40 over what? D2. So now by the time we cross multiply, what do we have? We have 1.3 times D2 equal to what? 40. Now divide both sides by what? 1.3. What do you have? Divide both sides by 1.3. What do you have? We have 40 divided by 1.3. You're having 30 point what? 30 point, approximately 30 point what? 30.8 cm. That's what you have. So from here we can progress. So the total apparent depth will be equal to D1 plus D2. I've already told you that before. And then if you do that, you're going to have 30.8 plus 5.7. What do you have? 30.7, sorry, 30.8 plus 5.7. What do you have? You have 36.5 cm. So for us to find the displacement, all we need to do is to subtract this one from the original depth. Remember, the original depth is 8 plus 40, which gives us what? 48. So we're going to have that the displacement will be equal to the real depth, which is d real minus the apparent depth, that will be d apparent. So if we do that, what are we going to have? 48 minus 36.5. And what do you have? If you do that, 48 minus 36.5, you can just do it. It will give you about 11 points. 11 what? 5 what? cm. My name is Mr. Oporom Darlington Chitachi. I'm here to help you with your mathematical and physics problems. Please do well to follow me on my YouTube channel, Darlington_. physics and any other platform you can follow me on. Thank you.